Welcome back to Mission Control here in Houston. We just mentioned a moment ago about the arrival of the Georges Lemaitre automated transfer vehicle launched a few weeks ago by the European Space Agency. One of the items that is in the ATV awaiting transfer and set up for scientific research is a very unique and novel experiment called Haptics One. Joining us today to discuss all of that is Dr. Andre Schiele, who is the head of the European Space Agency's Telerobotics Laboratory at ESTEC and an associate professor of mechanical materials and maritime engineering at Delft University of Technology in the Netherlands. Dr. Schiele, thank you very much for joining us today. It's a pleasure to have you on Space Station Live.
Thank you, Rob Navias. Thank you for inviting me.
First off, give us a sort of an overview as to what Haptics One is all about, and how excited are you personally to get this experiment on board and get it going?
Oh, I'm very excited. Actually, Haptics One is really a first-timer in the sense of the fact that never before a force-reflecting device has been flown to space. So we have been given the opportunity at my laboratory to build a force-reflecting joystick that would find its way up to the station and allow crew in the future to control robotic systems on the planet of Earth from the orbiting station. And you're seeing here a first test run that we did with some of the astronauts, Alexander Gerst and Barry Wilmore, during the ground training sessions. So that is a joystick similar to a normal gaming joystick that you would imagine, but very highly advanced. It includes a real-time computer. It includes some very high sensitivity force sensors in there that allows to actually perform position and force tasks by humans. Haptics One also has a tablet PC, and we implemented a revolutionary new approach on how to actually do crew-guided procedures. You're seeing here Barry Wilmore during the BDC runs, how he actually tracks an experiment, and the tablet PC actually guides the astronaut entirely through the experiment. So it is very similar to your usual iPhone that you have and an app that actually controls you automatically through all the menu items. And for space, this is pretty unique, and it sets the path for novel control stations in the future to come in order to allow astronauts to really interact intuitively with robotic systems on planetary surface or also outside the space station.
Dr. Andre Schiele, the principal investigator of the Haptics One experiment, joining us today. Dr. Schiele, what prompted your desire to develop such a novel and unique experiment?
Oh, actually, there are two really basic needs that we had. One was really a practical one. My laboratory has been tasked to conceive a more advanced robotic control station in the future, allowing to control complex robotic systems in the years to come. And in this frame, we will design an exoskeleton controller. So we decided it would be good to have a first test of the technology to actually implement on the station to run through the entire processes of verification, safety, medical certification. My laboratory is a rather small, agile laboratory within ESA, so we are 8 to 10 people, and we were thrilled to actually test out part of the development of that exoskeleton on a force-reflecting joystick, which already has all the computing infrastructure, the motor controls, and all the electronics for the later, more complex exoskeleton controller in place. Secondly, there was also a scientific rationale for this, being the lack of data of how humans behave in microgravity when controlling forces and positions. So we have a lot of experience on Earth how to use haptic feedback in robotic control, but we have not a single data point in space and actually microgravity. So we wanted to understand the principal mechanisms on how this works in a microgravity environment.
When are we expected to see Haptics One up and running?
Currently, the planning is to take place around 28 and 29 of September by Alexander Gerst, the ESA astronaut, who will be the first crew member to execute that set of protocols. There are 7 protocols that he will conduct that range from measuring all types of physical properties and technical properties of the system. And we hope that we will take those measurements on those dates. But knowing the infrastructure of the space station, some tasks are very high priority tasks, so there is some flexibility that it might take place a little bit later or even earlier.
And finally, Dr. Schiele, what ultimately will be the Earth-based application of this revolutionary technology?
Well, in Earth, there are a lot of applications. Basically, any application that requires tasks to be carried out in places where humans shouldn't be. Imagine the catastrophic events of Fukushima or Chernobyl, or also activities deep in the ocean like Deepwater Horizon, where robotic systems can go but humans can't go. For these sort of applications, we need robotic technology that allows to make the human feel present at the work site, even though it's only a technical system that is actually there. So the technology we are developing for ISS, being very intuitive to use, will directly benefit to those areas.
Well, it sounds like a fabulous opportunity and a great experiment coming up, and we can't wait to see the results and share them with you as they unfold. Dr. André Schiele of the European Space Agency's Telerobotics Laboratory, thank you so much for joining us today from the Netherlands.
Thank you, Rob Navias.